Welcome to Wiring Methods. Today we're going to talk about some basic beginner things about wiring methods. We're going to learn about some symbols. We're going to learn about wiring a basic wiring circuit, a drawing, and just sort of follow that along. We're going to work through the first couple of labs that you're going to be doing when you come in to class next week. So let's just start off with some symbols, right? So our first symbol is the symbol for a light fixture, right? For a light. It's a circle with 4 lines, and those 4 lines could either come out horizontally and vertically, or they could come out at an angle. Something else that you'll see pretty often, right, is you'll see 3 lines that are all the same length, and then maybe a fourth that's a little longer with a side on it, right? That's representing a pendant light, a wall mounted light. And so these are all symbols for a light that you'll get used to seeing. These all have to do with residential wiring. Most of the lab boards that we're going to work in this class are residential boards. So most of the symbols that we talk about are going to be talking about the residential boards. As you get further into classes, we'll talk about the way that some of these symbols change for commercial wiring. We've got the light. We've also got a switch, right? So if you've got a single pole switch, right, it'll just be an S or an S with a 1, right? And that is a single pole switch. This is just like the switches that you have, in your bedroom, right? So the light switch that you use to turn the light on and off is usually a single pole switch. Now, if that room has two exits, and you have a light switch at either exit, for those situations, you're going to have either a 3-way switch, or you're going to have a 4-way switch. Right? And so when you're looking at a blueprint, right, of a room, it may look something like this, and then you're going to have a light. You're going to have a doorway opening with, right, could have a single pole switch. If that room has 2 doorways, it has a door on either side, right, maybe we have 3-way switches, right? The other thing that you're going to see is you're going to see, say, a line coming in like this, maybe a dotted line between switches, maybe a dotted line up to the light. You could see a solid line here. Those are all ways to represent the wire that's moving between one and the other. Something else that you may see on that wire, right, is you may see a couple of long lines and a short line. Or maybe you'll see 3 lines and a short line. And what that is showing you is how many current carrying wires are inside of that wire, right, inside of that cable. So if we take a look at a piece of cable, right, say this is a piece of Romex, and it is this one right here, right? It's a piece of 12-2, right? 12-2 means it has 2 current carrying conductors, right? Our 2 long slashes, those are our current carrying conductors, right? One of those is going to be your black wire, right? The other, right, I'm going to do this in gray, but it would be white. White's not going to show up on my drawing here, so we're going to use gray in all of these to represent white. So our white wire, it's also considered a current carrying conductor because it's carrying the current back to the source. We'll show you how that works here in just a moment. And then so that takes care of our our current carrying conductors, right? We've got 1, 2 current carrying conductors, and then there will be a bare copper, right? and I don't have a copper colored line, so we're going to use green, right? Because if it had insulation on it, it would be green insulation. The green tells us that it is the ground. In Romex, that wire does not have a outer jacket on it, and so it's just bare copper. We're going to use green to represent that when we're doing these drawings. Now, another symbol that we're going to want to know is the receptacle. This is a duplex receptacle. Those two lines tell me that it is a duplex receptacle. Now, if it had a single line, that'd be a single receptacle. These are a little more rare. You don't see them very often, but they do make it. You should know the symbol for it, right? The duplex receptacle, that's the most common type receptacle. That's what you've got in your home, in your kitchen, in your living room. It's what you're plugging your phone chargers into. Is generally a duplex receptacle. Just like we spoke of with the lights, it could have a couple of lines coming out the side. That's showing you that it's mounted in a wall, right? It's a wall receptacle. It could also be inside of a box, right, with our lines, and that's going to tell us that that's a floor mounted receptacle. So that's going to give us, the basic symbols that we're going to need to get started. We're going to learn some more symbols as we go. We're actually going to have a unit on symbols where you guys are going to learn a lot more symbols. We're going to have a test on those, but these will be enough to get us started, right? Before we do that, though, we're going to talk about a basic wiring circuit, right? So a basic circuit, we're going to need a source of power. Right, so we have a battery here. And then coming from that battery, we have a wire that is going to run across, and we have a light bulb. Right? So we have supplied power to this light bulb, but our light bulb hasn't turned on yet. Right? So we are going to need a wire that's going to continue this circuit through the light bulb and back to the battery, and then our light bulb will come on. Now it'll come on and it'll stay on until we turn the battery, until we remove the battery. There's not any switches in this circuit, right? But if we were to break our circuit here, then our light goes off. So we can add a switch in here, right? Now we have a switch. And if I close that switch, right? If we close that switch, our light comes on. And if I open that switch, our light turns off, right? So let's imagine this as, instead of having a battery, right? If you'll notice we can let's get our eraser here. We're gonna close off that side there. So instead of using a black wire there, if we put our white wire in here, right, represented by the gray, now we've created a very simple circuit like it's in your bedroom, right? We have a light switch, and we have a light bulb, right? And it's just a very simple circuit. Now, in your home, right, you don't, most of you, very few of you, I would think, are going to have a battery-operated light running your bedroom. Right? In your home, you're going to have a panel, and in that panel is going to be a breaker with a switch, and it'll have a little set screw on it. And our hot wire will be connected directly to that breaker. And then there'll be a ground bar inside of a neutral bar inside of that panel. And our neutral will come in and attach to it. Right? And now this is our completed circuit. when this switch is flipped, our light bulb comes on. Well, let's see that in a closer to a real world example, shall we? All right, so I'm gonna need so this is that same circuit, a switch with a light, right? It's the exact same circuit, but this is actually showing us our switch and our light. This is coming out of your lab packet. We're going to work this together. You're going to have this lab done before you start on your lab next week. So if we look at this, right, we have a cable coming in to the first switch, and then we've got a cable coming out going over to our light, right? That's what we've got going. It's a 2-conductor with a ground. That's what those little dashes tell me, right? This is our single pole switch. This is our light. Let's clear all those out so that we can draw it in. I'm going to draw in my cable, right? My cable's coming to my first box. Then my cable, I have another cable that leaves that first box and it goes to my box where my light is going to be. Inside of that cable is a hot wire, right? And it's going to come up and it's going to tie to one of the screws on our switch. Well, what are we going to do with a white wire? Our white wire, it comes out of this cable. And where is it going to go? Well, if we look up here, we see that our white wire, it continues all the way across here without being broken, right? It doesn't get broken by anything. We're only breaking the hot wire. We're only breaking our black wire. Our white wire, it continues from the bulb all the way back to our panel without getting broken. Well, we've already broken it, right? We've already, because we're using more than one piece of cable here, we're not using a single piece of cable. This cable, this white wire, has already been broken and it's not connected to our light bulb. Well, all we're going to do here is we're going to take a wire nut and we're going to connect here and here, and then use this wire nut to make sure that that bond is good. We're going to connect those with a wire nut. So we have our white wire is our path for our white wire is going to go all the way back to our panel. Now then we can take our black wire, got our other black wire that's coming from our light. It's going to follow through the cable and it's going to tie to the opposite side of our switch. And then our black wire is going to get connected to the switch and it's going to get run over and connected to our light. So the only thing that is broken is the black wire, the hot wire. If we look back up at our example, that's exactly what we have. This very simple circuit. We have broken the hot wire with a switch. When the switch is turned on, the light comes on. When the switch is turned off, the light goes off. That's what we've created here. That's the exact same thing that we created here. Now, the only thing that we haven't shown here is we haven't shown our ground. Our ground would go inside of our cable here. It's going to go up and tie into our switch, and then you're going to also twist together from the other cable. These are going to be twisted together and hopefully with a wire nut. Tie these all together with a wire nut and then runs through this cable, and it's going to be attached somewhere on this light. Some lights would have a ground wire coming off the light. Some would have a grounding screw. The lights that we're using are actually very, very inexpensive lights, and they don't have a grounding screw. So we're going to just leave it dangling inside of our box, but we will touch on it. We will talk about it when you guys do that, as to where that's okay and where that's not okay. Now we're going to look at a receptacle. So we've got to do let me pull a picture of lab number 2 into our, there we go. So, same thing here that we talked about earlier, right? We have a cable coming in. We have a cable leaving that first box and going over to the other box. We see that it is, once again, a cable with two current carrying wires and one ground. So we will show that with these wires here. Now with the receptacle, we're going to come in, we're going to tie to the hot side of our receptacle. How do I know which side is the hot side? Well, I can tell the hot side of the receptacle because it's the short side. It has the side with the shorter hole. The side with the longer hole, that is our neutral side. It should also have brass screws where the neutral side will have silver screws. That's another way that you'll be able to tell the difference. And so we also have our neutral coming in. It's going to tie to the opposite screw. We're going straight across here from each other, right? Our hot on one side, our neutral directly opposite of it. And then our ground is coming in and it's getting tied to our ground screw. Now, our wires in this, this right here will actually, that first receptacle is now ready to turn on. If you flip the breaker for this circuit, that first receptacle it's going to run. But our second receptacle is currently dead. It doesn't have any power to it. So now we're going to run power off of the other screw on the hot side, right? We're tying into the other hot screw, and we are passing that through our cable to the hot side of our receptacle. Same thing with our neutral, tying that to the other screw, passing it through the cable to the neutral side of the other receptacle, the long slot side, the short slot side, it got the hot wire. And then our ground tying in, coming across and up to this ground screw. Now we have provided all of the wires that we need. If we turn the power on, both of these receptacles will run. It is perfectly okay to do it this way. This is not the preferred way of hooking up this circuit. While running the wires through the receptacle are permissible by the NEC, all of the current for any receptacles that are on this end down, right? If we had several more receptacles, all the current for those receptacles is passing through this tiny little piece of metal that's in between these two screws. There's a little thin piece of metal that connects those two screws that allows the continuity between these two pieces, right? That's allowing our power to pass through here and here. It's a little thin piece of metal, and that little thin piece of metal can fail. And if it fails, right, if we get if that burns through because of the amperage down the line, all the receptacles that are beyond this point will be dead. But if we wire this a little bit differently, we can avoid that, right? So we bring our hot wire comes in and we set it off to one side. Our neutral wire comes in, we set that off to one side. Our ground wire comes in, we set that off to one side. Now we take our cable coming from this cable, right, and we're going to tie those two together. Same with our neutral wire. We'll tie those two together. Same with our ground. Tying those together. Now our electricity can pass through. We haven't powered a receptacle yet, but our electricity can flow through as far as we want it to, right? If we do that in each box. Now we add a pigtail, right? At this point where we're putting these wires together, we're going to add a pigtail that's going to tie in right there. And on our neutral side, do the same thing. We're adding a pigtail that's going to tie into our receptacle right there. And then we're just going to use a wire nut to tie, to make sure that those are mechanically fastened together. Doing the same thing with the ground. And tying that together with our wire nut. And now on the opposite end, all we've got to do is our black to the brass screw, the short side, our neutral ties to the long side or the silver screw, and our green, our copper, our bare copper, our ground, it ties to the green screw or the ground screw. Now we've completed that entire circuit. Now, you will need to have a version of these drawn up and drawn correctly, right? You'll need to have them drawn correctly before we start on our labs next week. So be sure to take a look at these. There will be a follow-up video that actually shows me wiring up some of these receptacles and switches, so that you can get a sense of what I'm going to be looking for, what I'm going to be grading for, how far back to strip the wire, how to tuck it underneath the screw, how to make sure that we're not like having bits and pieces of conductive wire that are sticking out away from the receptacle where it could cause a short. All the things that we're looking for, we're going to be looking for things that are within code when we're doing these labs. And so I'm going to do a follow-up video showing me actually wiring a couple of those, where you can get a feel for that before we get started. We'll see you this coming week.